Assistive AI Educational Technology, Seminar 5, Group 3.4. Welcome. We are IMPI Technology, a startup specializing in providing assistive AI solutions. We welcome all senior representatives or leadership management from both public and private schools located in Wales. Our mission: providing a first-class system of identifying and mapping areas of improvement for students, designed to work with the teacher and for the student using assistive AI. Now let's talk a little bit about what AI really is. AI is the study of intelligent agents, any device that perceives its environment and takes actions that maximize its chance of successfully achieving its goals. The taxonomy we thought would be useful to use in further understanding AI is the categorization of mechanical, analytical, intuitive, and empathetic. These categories refer to the AI ability to perform repetitive tasks and process information, such as in mechanical and analytical, to thinking creatively and recognizing emotions for intuitive and empathetic. Our assistive AI solution is going to be a mixture of these categories. Specifically for our proposal, we would like to focus on assistive AI, which represents AI that supports users in making better decisions and providing increased efficiency on the task level. For a wider context, assistive AI is one of the three types of AI in addition to automated and autonomous, which are not a part of our proposed offering. Key to keep in mind is that AI is assistive and aims to support human users. Moving on to the chosen technology. From our systems perspective, we see the AI algorithms analyzing multiple data points to provide valuable insight to the teacher. For the first iteration of the system, we aim to focus on three technological features. The first being usage of supervised machine learning to connect identified knowledge gaps to different sections of available teaching. That would be curriculum, different classes, skills, etc. Second, use of natural language processing, NLP, to analyze essays, pieces of work, to provide tangible recommendations on which areas to improve and an overall view of how the class is performing. And lastly, usage of video and speech analytics to assess students' presentation and provide feedback on the performance. For example, body language, voice projection, etc. Now let's take a look at some real-life examples of usage of AI in education. Three different domains of artificial intelligence have been identified among the plethora of different use cases of companies and startups we came across, and we would like to highlight three of them. Firstly, a learner-facing artificial intelligence solution, which is usually defined as a software that students use to receive and understand new information, which respond to an individual student needs. Learner-facing tools are often referred to as intelligence tutoring systems or adaptive, personalized, or differentiated learning platforms. The first example we would like to discuss more broadly is Sentry. Sentry, which is an adaptive learning platform that uses AI to make decisions about the best pathway through learning materials for a specific student. As students learn, answer formative assessments, and complete diagnostic tests, the platform's AI gauges their strengths, weaknesses, and gaps in knowledge. This enables the platform to provide appropriate scaffolding to support learning. Its built-in assessment tools can reduce the amount of time spent marking, while insights from data analytics provide insights for teachers on students and class progress. The result is often that teachers are able to provide more effective individual support for those students who need it. Secondly, a teacher-facing artificial intelligence solution is a one that assists teachers reduce their workload, gain insights about students, and innovate within a classroom. It provides support among the following. 1. Automates tasks such as assessment, plagiarism detection, administration, or feedback. 2. Provides insights about the progress of a student. 3. Help teachers innovate and experiment. For example, facilitating different methods of teaching or helping teachers organize students into small groups based on shared characteristics. The second example we would like to discuss is class charts, which represents an automated seating plan tool and behavior management software driven by artificial intelligence. It aims to save teachers time and reduce workload through data-rich seating plans that reduce behavior problems. The class charts platform allows teachers to monitor pupils' achievements and behavior, while the class charts technology tracks how pupils influence each other. And lastly, a system-facing artificial intelligence solution, which helps make or inform decisions made by those who are managing and administrating schools or the education system as a whole. This is the least widespread category of AIED with the fewest number of existing tools identified, since often system-facing tools require sharing of data between schools and colleges, rather than just within a single organization, which can explain why this type of solution is not very widespread. Following a trial run by the Behavioral Insights team in 2017, Ofsted has been using supervised machine learning to identify which schools should be prioritized for a full school inspection since the summer of 2018. This involves training an algorithm which uses datasets from across many schools. Now we're going to take a look at today's situation. According to the PISA test, the United Kingdom is placed 15th out of 79 countries and regions, which marks out a positive progress compared to previous test results. PISA is the OECD's program for international student assessment. PISA measures 15-year-olds' ability to use their reading, mathematics, and science knowledge and skills to meet real-life challenges. However, it is important to note that these tests are voluntary, but increasing number of countries choose to take part, wanting to see how their pupils compare by an international standard. However, going deeper into United Kingdom's education system, we have noticed that Wales is lagging behind the other three regions. In reading only, Wales scored below the average for OECD countries, while England, Scotland, and Northern Ireland were all above average. An OECD report has identified four main challenges that need to be met to improve the quality of education in Wales in the long run. These include a large proportion of low performance and diverse students whose needs are not being sufficiently met in schools, inadequate conditions to nurture an excellent teaching profession, lack of synergies in the assessment and evaluation arrangements, and lack of long-term clarity in policy making with weak implementation approaches. An overarching challenge is that Wales lacks a compelling and inclusive long-term education vision to steer the education system and its reform efforts. As the OECD reports illustrates, the average reading scores of England, Scotland, and Northern Ireland remain above OECD average, from 2006 to 2018. Nevertheless, only Wales remain below the average. This underlines the significance of helping the Wales education to keep up with the average level or even surpass it. Which brings us on to our solution. We will provide a assistive AI solution that identifies areas of improvement, maps relevant pieces of curriculum, and empowers the teachers to create personalized teaching materials. Our solution is a teacher-facing AI which is equipped with three fundamental tools based on natural language processing, audio and visual technologies, and AI model. Firstly, we provide a built-in automated text analysis tool that analyzes students' homeworks and tests. Homework reports and other documents and test-related reports will be generated automatically. Secondly, we provide a built-in presentation analysis software that examines the student's presentation outputs. After being viewed, the software will analyze the presenter's movement, clarity in speech, and presentation consistency. Thirdly, we provide an automated text analysis tool that analyzes the curriculum and links it back to the student's feedback. As mentioned, our solution is a teacher-facing AI, which means that only teachers can get access to the data and use the reports generated to provide suggestions. The homework and class involvement reports can assist teachers to identify strengths, weaknesses, or gaps of a student's knowledge, and thus suggest students personalized learning materials. At the same time, based on the reports, especially homework reports, teachers can get insights regarding how to improve their own teaching material and capabilities. For example, for a math teacher, if the reports illustrate that the majority of the students fail to answer questions about the weighted geometric mean, the teacher can put more effort into helping students to understand the magic of the geometric mean. Now that we understand the assistive AI solution for our WELS teachers, what's the actual data for the assistive AI we'll use? We have identified three types of data assets that would be crucial for the system to be successfully adopted. Student outputs. This means essays and documentations that students provide, which will be digitized and entered to the system. Feedback. This is detailed feedback provided by the students on how they believe they are doing and where they feel gaps in the learning and the materials. Video material. Here we get information of how students are presenting in classrooms and what areas of improvement they might have. The clarity of speech. The risks that are identified for the implementation of our solution have been grouped into customer facing and back office facing. On one hand, we identified risks that have a direct relation with the student and the parents. We call them the customer facing risks. Among them are evident ethical issues due to the gathering of such sensitive data. This point also includes the trust of parents and students and willingness to adopt a new AI based system. Besides, there are risks of high expectation on AI technology, which could lead to unfulfilled expectations on the technology. Lastly, from the customer-faced perspective, the segregation of the students after personalized ways of teaching is also a concern to put into consideration. On the other hand, we have identified different internal types of risk, which we have called back office ones. These are regulatory changes of AI technology, particularly in the terms of explainability, data storage definitions, and governance risks between the educational authorities. All of them will be assessed and mentioned with the solution in the following slide.